Hey guys, my name is Adithya C, and I'm going to take a short session on an introduction to LT Spice. So before I start off, here's a little bit about myself. So I'm a second year student pursuing a degree in electrical engineering from the National Institute of Technology, Karnataka, Surathkal. And my interests revolve around sports. I love sports, especially badminton, being a player myself. And I love watching a lot of TV shows, especially binge watching. And my hobbies include collecting stamps. So without further ado, let's start off with the session.
LT Spice is basically a computer software which is used for implementing spice-based electronic circuits, mostly for simulation, and it was produced by this manufacturer called Linear Technology. So now they're a part of this company called Analog Devices. So what Spice is, it's basically a simulation program with integrated circuit emphasis, and it's more of a general purpose electronic circuit simulator. It's extremely widely used across the industry, and circuit design is also an important component when it comes to your embedded side. And so why LT-Spice? So first off, it's free compared to other softwares like PSpice. So you don't have to pay anything to use the software. Installation is extremely simple. You can just go onto their website and download the installation files for Windows, Mac, or Linux. And the software is extremely easy to use and master. So I'll just be showing two simple circuits today that will help you kickstart your journey in circuit design. There are a lot of documentation available, a lot of tutorials on YouTube. Even Spark Fun provides good introductory tutorials. They have some documents that you can go through. I've just put up this in the resource sections in the end, so you can refer to that. So, all right. So the best part about circuit design is you actually get to visualize what you're doing. So we'll dive right in without going through any theory. Just assuming you have a basic knowledge in circuit. So we'll start designing a simple circuit. So on the toolbar on the top, you can see a lot of different symbols. So I'll just be explaining some of the most useful symbols that you'll probably be using every time you make a circuit. So you start off by creating a new schematic, and that is with this play type icon. So once you've done that, you'll have a blank screen, and these icons will be there in the toolbar, which you can start using. So first off, we'll start with the components. That looks like an AND gate. So that is used to add any component that you want into the circuit. So, and for some of the components, there are predefined symbols like R, resistors, capacitors, and inductors. You can use the symbols, or you can just press the key R on your keyboard and you can add a resistor directly. Same goes for capacitors and inductors. So the different type of diodes, you can access them by clicking on the diode symbol. The ground and wire symbols and the label symbols are also pretty useful. So for example, you want to label a node, assuming you have a simple circuit and you want to label a node to find out the voltage at that point, you can use your label and create a label to that node. And once you run your circuit, you can find out your parameters. And finally, the move and drag icon. So once you click on it, you'll be prompted to draw a small rectangle. And whatever components are inside the rectangle, you can either move them to a different location or create copies and stuff. So finally, the cut icon is used to remove any component on your schematic, and the run icon is to simulate your whole circuit. So okay, so let's just dive into a simple circuit. So here we'll just create a simple circuit with a source and two resistors, and we'll find the value of the voltage at a node between the two resistors. So first we'll start off by adding the components. So you click on the components icon, so which looks like an AND gate, and you search for voltage. So then you'll be then when you click on OK, you can add the voltage source. So as shown here, and by clicking R, you can add a resistor. So and to rotate a resistor, you'll have to press Control R. So that will give you the resistor rotated by 90 degrees. So here, and if you press G, you can add the ground. So what I've done here is I've added a single source, two resistors, and a ground. And using the wire icon, I have wired them in such a manner. So here you can see two of the nodes have a little dark blue square on them. So that means it's a node, and if there are two wires crossing and there is no blue square there, it means that they're not connected. They're electrically isolated, and probably they go on top of each other. And I've also added a label here with the name value here. So on running my circuit, I will get the value of this label. So at this node, I will get the value of my voltage. So all right, so now let's assign the values. So as you can see here, the values are just V, R, and they're not any fixed values. So how you'll assign them is you have to right click on the component. So for the resistor, the name of the resistor is R2. So you can assign the value over here under resistance. So for this case, I've assigned the value of R2 to be 10K and the value of R1 to be 20K. And tolerance and power rating, they're not really required. But in a more complex circuit where those values might make a lot of change, you can add them up. And for the voltage source, you can similarly right click and add a DC value. So for my simulation, I have given the value of 5 volt. So I mean, it's totally your choice. And the series resistance is not required. So and if required, you can add the value here. So finally, to test this circuit, we'll go to the run icon, and over here under these tabs, we'll choose the DC operation point, and then we click on OK. So, and this should give you a pop-up window as shown. And as you can see, the value of voltage that I've chosen is 5 volt, and the value here, so that is 3.33 volt. I've given R1 as 20K and R2 as 10K, so that the output should be 2/3 the voltage, 2/3 my input voltage, which matches here. And here are some other parameters that it has computed for you. So that could be the current through R1, current through R2, and current through IV1. So this would be for a simple DC system. So now finally, I have another example on transient analysis. So following a similar procedure as before, I've added in a voltage source, a resistor, a ground, and additionally, I've added a diode component here, and I've wired them up in the following manner. So now I've chosen the value of the resistor as 10K, as you can see. So now what I'll be doing, I'll be choosing the value of the diode. So for the diode, generally for such components, you have like a lot of companies having different diodes with different specification. So you can search by the part number. So here I have chosen the 1N4148. You can see it on the next screen. So based on your requirements, like different breakdown voltages and different currents and different types like Schottky diode, silicon diode, Xeno diode, and different manufacturers, you can choose a specific model. So here for me, I was just fine with the simple diode. But when you are designing a system and suppose you want the Xeno diode, then you can search from the list below and you can choose the one that suits your needs. So now I click on OK. So now I choose the voltage source. So here, instead of providing a DC source, I'll be giving a sinusoidal source, AC source. So instead of choosing the DC value here, what you do is you click on Advanced, and this gives you a huge window. So under this, you can choose the sine function. So I've given an amplitude of 10 volt and a frequency of 50 hertz. So the additional parameters, I've left them blank, but if required, you can add a series resistance from the right here, or you can give it a DC offset, change the delay. And there are a lot of parameters that you can play with. You can change it to an exponential source or a pulsating source. It's totally your choice. And so next, all you have to do is, instead of going to DC operation point this time, you will click on transient because you want the transient analysis. So now that I've given the frequency as 50 hertz, you must know that the time period of one cycle will be 0.02 seconds. So I just wanted to check my output for 2 cycles. So I've given the stop time as 0.04. And when you click on OK, on your screen, you should see a small text that says .tran 0.04, and it should give you your simulation output. So once you click on the wire above the source, you can see a red color marker that comes up. So that should be your voltage probe. And when you click on it on a wire just above the source, as expected, you can see 2 cycles of the input waveform. It's a sinusoidal waveform with 50 hertz frequency and an amplitude of 10 volt. So now if I do the same, but I click on, I use the voltage probe on the wire next to the diode, you can see that as the diode will be forward biased only in the positive cycle. So you will get the outputs as only the positive cycles. And the voltage won't be exactly 10 volt. There might be like 500 millivolt different, probably due to the addition of the diode. And so now you can add multiple waveforms onto the screen. You can view multiple waveforms. So finally, I've chosen the source and the diode output waveforms to be shown. So here's the source in the blue color and the diode output on the green color. So you can make much more complex systems. This is just a simple introduction. And so finally, now that you know how to start off with LTSpice, so where can you improve your knowledge using some references? So the LTSpice documentation has it all. It's a really useful source. I would prefer you using documentations from SparkFun. So they have some good videos to start off and build simple systems. And there are a lot of tutorials on YouTube. If you have a small doubt, and you can just Google it and find some YouTube videos of the same. So you can just implement it the same way they've done. So thank you for attending this session. Hopefully it was useful.
Thanks for watching. Subscribe and click on the bell button as to not miss out any content. Contact us here.